Welcome to Ask and Learn.
Okay, so here we'll just call this algorithm maximum attendance. I'll just put max A. Okay, we want the input to be a list of start times. So it's going to be S1 to Sn, the list of start times of the talks, as well as the list of the end times. So we have E1 to En being the corresponding end times. And we need one more list, which is the number of attendees that corresponds to each talk. So we'll let that be a W, so W1 to Wn. And so the idea would be that S1 would be the start time of talk 1, E1 would be the end time of talk 1, and W1 would be the number of attendees that could go to that talk. So number of attendees. So the first thing we're going to want to do is sort one of these lists. Okay, so we want to sort the talks by the end time. Okay, so we're going to sort the talks such that the first end time is less than or equal to the second end time, all the way up to the last end time, right? So now our talks are in order by which they end. And so the first thing to do is determine for each talk if there are any talks with earlier end times that are compatible. And so what that means is if a talk, say, ends at 1, right, anything that starts after 1 would be compatible with it. Okay, so we express that by saying for j that runs from 1 to n, if there is no talk so talk I being these like indexes with I less than j, is compatible with talk j, then we're going to set p of j equal to 0. Alternatively, so if something is compatible, then we will set pj equal to the maximum. And so we're setting it equal to the maximum number of compatible talks, right? So depending on how these overlap, it could be compatible with 1 or 2 or 3 or more talks. And so we want the maximum number. Okay. And with the maximum number where I is less than j and talk I is compatible, and I'm just going to put COMP for compatible with talk j. Okay, so I'm going to move on a few more steps here. We're going to let Tn keep track of the maximum number of attendees at any given point. So we're going to want to initialize it to 0. And we'll also let S of n keep track of the tracks that maximize the number of attendees, right? So S of n is going to need to initially be defined as the empty set. So this is going to kind of keep track of all the T T values that we get. Okay, so now those are initialized. Talk J belongs to an optimal solution only if the number of attendees for Talk J plus the number of possible attendees to all the things it's compatible with, right, is greater than or equal to the number of attendees from the previous step, right? So only if we are increasing our number of attendees do we want to let Talk J be involved in our optimal solution. So to encapsulate that idea, we'll say for J as it runs from 1 to n, so as it scrolls through all of our talks, and T was keeping track of the maximum number of attendees at any point in time. So the maximum number of attendees is going to be equal to the maximum number of the people that can attend that Talk J plus the folks that can attend, so like the maximum number of attendees up to that Talk J that are compatible, or the case where we don't involve Talk J at all. So it's either the maximum of including Talk J or the maximum previously not including Talk J. And so if the value where we include Talk J here is greater than if we don't include this talk, then we will set S of J equal to S of Pj with J, right? So this is keeping track of our list of talks. And if not, then we will set S of J equal to just S of J minus 1, so without it. So we're either saying the best case is to include J in our list of talks or not. But once we have encountered J in our list, we're taking care of both cases. And finally, we just have one more line, so I'm going to put it to the side here. But we just need to return our T, it's our number of attendees, and our S, the list of corresponding talks.